Good evening. Welcome to the session. Continuation of circuit theory, that is network theory concepts. With respect to chapter 1, that is fundamentals of electrical circuits, I am starting the lecture 5. Students, in the previous session that I discussed about the concept of inductor, what the definition of inductance, how to calculate the inductance, and how to calculate the power in inductor, how to calculate the energy stored in inductor. All these concepts I discussed, and what the properties of inductor. Now, you have to see one more important element, circuit element, that is the capacitor. What is the capacitor and what is the capacitance, and what is the energy stored in the capacitor, then what are the properties of capacitor, then how to calculate energy stored in the capacitor. Then after that, we'll see some energy calculations in resistor, inductor, and capacitor. Then we go for the different types of elements. Students, we know that if two conducting plates are separated by if any dielectric medium, then it acts as a capacitor. It is an arrangement of two conductors generally carrying charges of equal magnitudes and opposite sign and separated by an insulating medium. This is called capacitor. That is, two conducting plates are separated by any insulating medium, that is dielectric medium. Then we can say that it acts as a one capacitor. That is what exactly capacitor. Capacitor is the physical element. Then what is the capacitance? Capacitance is the property of capacitance. The non-conductive region, whatever the dielectric medium or insulating medium is there, the non-conductive region can either be an electric insulator or vacuum such as glass, paper, air, or semiconductor called as a dielectric. This is used as a insulating. Friends, we know that inductor stores the energy in the form of magnetic field. The magnitude of magnetic field is determined by using two laws. One is Biot-Savart's law, another one is Ampere circuital law. Now the question is, in what form the capacitor stores the energy? The capacitor stores the energy in the form of electric field. The capacitor stores the energy in the form of electric field. The form of electric field. It stores the energy in the form of electric field. But what is the magnitude of electric field? The magnitude of electric field is determined by using two laws. The magnitude of electric field is determined by using two laws. One is using Gauss law, another one is using Coulomb's law. That is, magnitude of electric field is determined by, magnitude of electric field. The magnitude of electric field is determined by electric field is determined by one is Gauss law, another one is Coulomb's law. This statement you have to know. One is Gauss law, another one. What exactly Gauss law? What is the Coulomb's law? All these that you see in your EMF subject for ESE students, that is EMTL subject. Then according to Gauss law, how to write the electric field E equal to, one of the formula is lambda by epsilon. You can also write this is equal to V by D, where lambda is taken as a surface charge density. You have to take what is the lambda here, friends? Surface charge density. Here instead of lambda, they taken sigma. You have to take any notation, no problem. Yeah, this is the surface charge. This is the electric field E equal to lambda by epsilon. That is equal to V. But friends, we know that whenever voltage is applied, let's assume that in capacitor there is two plates, two equal charges on each plate. but it is a opposite polarity. This acts as a capacitor. If you apply voltage across the plates, if you apply this any voltage across the plates, that V voltage is applied across the plates. The voltage is applied. What is V here? V is the work done per unit positive charge in taking a small test charge from minus Q to plus Q against the electric field. Already potential is nothing but work done per unit charge. Work done per unit charge. Where V is the work done per unit positive charge in taking a small test charge from minus Q to plus Q against the electric field. How much voltage you have to apply to bring this from minus Q to plus Q against the electric. To transfer the more charge, you have to apply the more voltage. If you have to transfer this charge from minus Q to plus Q, students, if you have to transfer the more charge, we can apply the more voltage. That is, if the more voltage is applied, more charge is transferred. This I am writing. To transfer the more charge, we have to apply more electric field. To transfer more charge against electric field, we have to apply more voltage. Apply more voltage. Apply more voltage. That means what is the observation here, friends? What is the observation? How much charge is transferred? That is proportional to the voltage. How much charge is transferred? That is proportional to the voltage. If you remove the proportionality, we can get proportional constant, that is Q equal to C. We are getting a proportional constant C, that is Q equal to CV. From this, how to calculate C equal to Q by V? This is called capacitance. This is called capacitance. Students, I explained the every concept of element, resistor, inductor, capacitor. See the concept I explained. V proportional to I, V equal to IR. This is the proportionality constant. Psi proportional to I, then psi equal to Li. This is the proportionality constant. Like that, Q proportional to V, Q equal to CV, where C is the proportionality constant, C equal to Q by V. Okay, that is the capacitance. Then what is the units of capacitance, friends? The units of capacitance, one of the unit is, this unit is Coulomb per volt. Coulomb per volt. This is the one of the units. Coulomb per volt. Or the other units of capacitance, generally capacitance is measured in microfarad or nanofarad or millifarad. This is measured in nanofarad. Other unit is farad, but this is measured in nanofarad. We can also measure the capacitance in microfarad. We can also measure the capacitance in millifarad, or simply we can measure in farad. It is in nanofarad, microfarad, or millifarad, or farad. Like this, capacitance is measured. Then how to define the capacitance? Capacitance of a conductor is a measure of ability of the conductor to store charge on it. Higher the capacitance, higher the storage of energy. Capacitance of a conductor is a measure of ability of the conductor to store the charge on it. Amount of charge stored by capacitor per unit potential difference. Amount of charge stored by capacitor per unit, this is definition. Amount of charge stored by capacitor per unit potential is called capacitance. This is the definition of the capacitance. You know that capacitance is formed by separating the two conducting plates with the dielectric medium. That is the capacitor. Capacitor is the physical parameter. What is the capacitor? Capacitance. Capacitance is the property of capacitor. How much charge is stored by capacitor per unit potential difference is called capacitance. Then if you draw the characteristics between Q and V, students, if you draw the characteristics between Q and V, is Q equal to CV? Q equal to CV. If you draw the characteristics, then this is Q and this is V, we can get the linear characteristics. Then the slope of this curve, Q equal to CV. That is, what is the slope of this curve? C equal to Q by V. Na? How to write a slope of the curve? How to calculate? Just this I am writing the C equal to Q by V. C equal to Q by V. This is equal to constant because of linear characteristics. This is constant. Because of what characteristics? It is a linear characteristic. In linear characteristics, that is a linear characteristics. For linear characteristics, friends, C is independent of Q and V. Independent of Q and V. Is independent of Q. What do you mean by linear characteristics? For example, if the voltage is increased by 20%, if voltage is increased by 20%, if V is increased by 20%, then what about the Q also? Q is also increased by 20%. Then you can say that it is a linear. What do you mean by non-linear, sir? What do you mean by non-linear? If V is increased by 20%, then Q is increased by 10%, then we can say that C is not equal to constant. C not equal to constant. If C not equal to constant means, then it depends on Q and V. Depends on Q and V. C depends on Q and V. It is a non-linear characteristics. This is the big difference between linear and non-linear characteristics. Linear and non-linear characteristics. Now, how to derive the what is the formula for capacitance with respect to dimensions of the plates? Students, I told already, according to Gauss law, the electric field E equal to lambda by epsilon. This is the electric field. The electric field E equal to lambda by epsilon. You can also write the electric field equal to V by D. The electric field is also equal to V by D, that equal to lambda by epsilon. But what the lambda I told friends, that is the surface charge density. Lambda equal to surface charge density. Surface charge density. How to define the surface charge density, sir? This is equal to Q by A. Charge per unit area, that is nothing but a surface charge density. That is equal to Q by A. Now we have to substitute here. V by D equal to lambda is Q by A epsilon. Q by A epsilon. How to write lambda equal to Q by A epsilon. But what is Q, friends? The charge equal to Q equal to C. Now substitute Q equal to CV. This Q equal to CV here. Then what formula you can get? That I am writing here. Q equal to CV. Just a minute. I am writing the slide. Sorry. How to write? How to write here? V by D equal to, this I am writing V by D equal to, I am substituting Q equal to CV, Q equal to CV by A epsilon. Then this V cancel. What is C equal to, friends? C equal to A epsilon by D. This is very important, 5-star gunshot form. The capacitance C equal to A epsilon by D. We can also write epsilon equal to A into epsilon naught into epsilon R by D. Yeah, this is the capacitance formula. A into epsilon naught into epsilon R by D. What is this epsilon equal to? Permittivity. Epsilon equal to permittivity. This is equal to epsilon naught into epsilon R. Epsilon naught into epsilon R. What is this epsilon naught? Epsilon naught equal to permittivity of free space. We know that in inductance calculation, we define the permeability. Here we are defining the permittivity. Then permittivity of free space. What is the permittivity of free space, friends? That is 8.854 into very important values, 10 to the power of minus 12 farad per meter. What is mu naught? 4 pi into 10 to the power of minus 7 Henry per meter. But this is 8.854 into 10 to the power of minus 12 farad per meter. What is the epsilon R? So epsilon R equal to relative permittivity. Relative permittivity. If air is the dielectric medium, that is for air, if air is the dielectric medium, epsilon R equal to 1, friends. If air is the dielectric medium, the epsilon, that is the relative permittivity of air, for air, epsilon R equal to 1. How to use different dielectric materials? No doubt at all. You have to use, that is epsilon R depends on the medium between the plates. Epsilon R depends on medium between the plates. Medium. What type of dielectric medium we are using? Medium between plates. This epsilon R equal to, for air it is 1. If it is a polyester material, how to use? If you use a polyester, this epsilon R is nearly equal to, this value equal to 6. If it is a glass, for glass, if glass is the dielectric, then what is the epsilon r value? The epsilon r is nearly equal to 200. It is based on the type of material we are using between the plates, the dielectric medium, the epsilon r value is changed. If it is air, for air, what is the capacitance? C equal to A epsilon naught into epsilon r by d. Then epsilon r equal to 1, you have to substitute, then A into epsilon naught by d. A into epsilon naught by d. Yeah, this is the calculation of capacitance. The calculation of capacitance that you have to consider. Clear, students? These calculations are very important. Now, your doubt is, sir, you are telling that capacitor is a two plates are separated by dielectric medium or insulating medium. Now we are applying the voltage. Then how the current is flowing in the plates? You are telling that it is a dielectric medium. Now? Then how the current is flowing? What type of current is exist in the capacitor? That is the doubt. Two plates are separated by dielectric medium or insulating medium. Then what type of current is exist in the capacitor? That is the question. Then what is the answer for this question that you have to consider? How the current is flowing through the capacitor? How the current is exist in the capacitor? See the detailed explanation. The dielectric materials have no free charges. I told already, in between two plates, we are using the dielectric material. These dielectric materials do not have any free charges because all the electrons are bound and associated with the nearest atom. That is, the electrons are bounded to atoms. Because of that reason, the electrons are bounded to atom in insulating materials or dielectric material. Because of that reason, there is no any free charges. The polar molecules in the material will be in random alignment. These are arranged in different fashions. These are molecules, these are in random arrangement, random alignment. When there is no peripheral electric field as shown in figure. If you don't apply any electric field, all these molecules are in random in nature. Now the question is, if you apply any electric field, then what happens? If you apply any electric field, this is in random nature without any electric field. Without electric field. These are random in nature without electric field. Now, if electric field is applied, what happens? When an electric field is implemented to this material, it will get polarized by aligning the dipole moments of the polar molecules. Whenever electric field is applied, there is a formation of the dipole. The positive charges within the material are shifted slightly in the direction of electric field. We are applying in this direction. All these positive charges are shifted in the direction of the electric field. These are randomly aligned, but now these positive charges are shifted along the electric field. And the negative charges in the direction opposing to direction of electric field. These are all negative charges. This is positive charge, this is negative. Positive charges are shifting like this, negative charges are shifting. Positive charges, negative charge. Positive charge and negative charge. Positive charge and negative charge. That positive charge is shifting in the direction of electric field, negative charge is shifting in the opposite to electric field. It transfers of electrical energy through the shifting of current and not through the process of conduction. These two charges are displaced by some distance, two charges. If there is a positive charge and negative charge, friends, it is displaced by some distance. This is called electric dipole. And this process is called, the process of formation of electric dipole is called polarization process. This is called a polarization process. That means whenever electric field is applied, whenever external supply is given for the capacitor, there is a process of formation of the electric field that is called electric dipole. Here, the electrical energy is transferring not because of the conduction. The electrical energy is transferring because of shifting of the charge, negative to positive, positive to negative, negative to positive, positive to negative. Like this, the electrical, like this, negative to positive, positive to negative, negative to positive. Like this, the electrical energy is transferred not due to conduction process, because of the shifting of the electrons. That is, in capacitors, friends, in capacitors and insulators, even in insulators also, the current is due to displacement current. What type of current is exists? Displacement current. Because of displacement of charge, we can get the current. That's why it is called displacement current. This is the reason. This is answer for this question. How the current is exist in the capacitor even though dielectric is present. Yeah, this is the answer. In capacitors and insulators, mainly what type of current is exist? Displacement current. In insulators or even in dielectrics also, that is a displacement current. I'm asking one question. In conductors, what type of current is exist? Can anybody answer? In conductors, what type of current is exist? Because of conduction of the electrons now, that is nothing but a drift current. What type of current is exist? Drift current. In conductors, the current is nothing but a drift current because of the flow of the electrons. What about in semiconductors? Can anybody? In semiconductors, what current is exist? In semiconductors, the current is exist because of two processes. One is diffusion current is exist and drift current. Diffusion current. What do you mean by diffusion current? Because of the concentration difference. Because of the doping concentration difference also current is exist. That is a diffusion current. Another one is drift current because of flow of charge. This is a drift current. This is important observation that in capacitors or dielectrics or insulators, in what type of current? Displacement current. Because of displacement of charges, we are getting. In conductors, drift current. In semiconductors, there is a diffusion current and a drift current is exist. This is how the current is flowing in the capacitors. With this knowledge, how to write some formulas with respect to capacitor. Very important formulas. How to do some important calculations. Let's assume that this is the capacitor. We are allowing the current through the capacitor. Let the current through the capacitor is I. This is the capacitance. The voltage across the capacitor is V. Then how to write the current through the capacitor, friends? How to write current through capacitor? The current through capacitor is written as, let the current through the capacitor is, this is I, that is equal to IC. That is IC equal to, any notation you have to follow. I equal to C into dV by dt. The current through the capacitor equal to IC equal to I equal to C into dV by dt. That is the voltage current through the capacitor. Then how to write voltage across the capacitor? The voltage across capacitor. How to write voltage across capacitor? To calculate the voltage across the capacitor, you have to write I equal to C into dV by dt. From this, what is dV? Sir, how to calculate dV? From this, what is dV? This dV equal to, so I'm writing, this dV equal to 1 by C I dt. Then integrate both sides. Integral dV equal to 1 by C integral minus infinity to t. Why I taken minus infinity to t? Because a capacitor is an energy storage element. That's why you have to take the from negative to positive minus infinity. Then you can write after integrating this V equal to 1 by C integral minus infinity to 0. This is I dt. This is correct. I dt. Correct now. This is I dt. Integrate both sides. That is I dt. Then I dt plus 1 by C integral 0 to t I dt. From this, what is the voltage across the capacitor? This is the, let's assume that this is the initial voltage across the capacitor. Vc of 0 plus 1 by C integral 0 to t I dt. Okay, this is the voltage across the capacitor form. This formula is voltage across capacitor. Voltage across capacitor. What is the Vc of 0, sir? This is the initial voltage across the capacitor. Initial voltage across the capacitor. Voltage across capacitor. If initial voltage across the capacitor is neglected, if initial, yes sir, voltage across capacitor is neglected. If initial voltage across capacitor is neglected, then you have to write what is the voltage across the capacitor? 1 by C integral I dt. The voltage across the capacitor equal to 1 by C integral I dt. This is the calculation of voltage across the capacitor. Yes. Now the question is, I have to, just like whatever I explained in the inductor, in the properties of inductor, same properties that I have to explain for capacitor also. See the note points, very important observations that you have to concentrate. We know that the current through the capacitor I equal to IC equal to C into dV by dt. Students, at t equal to 0, at t equal to 0, t equal to 0 means initially. at starting. Substitute t equal to 0 here. What is I you can get? T equal to 0 means I equal to infinity. Anything by 0 is infinity. At t equal to 0, infinite. Infinite current means open circuit or short circuit, sir. Short circuit. That is, initially capacitor acts as a short circuit. Short circuit means current is exist, voltage 0. Under short circuit condition, current is exist, voltage 0. Voltage 0 means it cannot allows the voltage. Understand the concept, sir. At t equal 0, I am getting the current is infinite. Short circuit. Current infinite means short circuit. Short circuit condition means voltage 0. Therefore, capacitor, very important property, capacitor cannot allows sudden change of voltage. Why I am telling this property? Because short circuit, sudden change of voltage. This is one property. Initially, capacitor acts as a short circuit. Capacitor acts as a short circuit. Initially, capacitor acts as a short circuit. This is one observation. Next, one more note I am giving that you have to concentrate. For the voltage across the capacitor, 1 by C integral I dt. Now, in this case, you substitute if t equal to 0. If t equal to 0, for t equal to 0, friends, then what is V? 0. Voltage 0. Or instead of this, not required this one, voltage, you have to take a, at t equal to infinity, you take. Same formula only you take. Again, not required this, you take a, at t equal to infinity. At t equal to infinite. In the above formula, you substitute t equal to infinite. If t equal to infinity, what the current? 0. Anything by infinity 0, substitute t equal to infinity here. Anything by infinity 0. Current is 0. Current 0 means open circuit or short circuit. Open circuit. Therefore, finally means at steady state condition. Finally, that is at steady state conditions. Yes. At steady state, whatever the capacitor acts as an open circuit. Capacitor acts as an open circuit. At starting, initially capacitor acts as a short circuit, finally capacitor acts as a open circuit. Exactly opposite to inductor properties. We know that capacitor stores the energy in the form of electric field. Capacitor stores the energy in the form of electric field. In which field it stores the energy? In electric field it stores the energy. I have to find what the expression for energy. For that, first I am calculating what is the instantaneous power in capacitor. Instantaneous power. The instantaneous power in capacitor. How to calculate, friends? The instantaneous power in capacitor, P equal to V into I. V into, what is I? C into dV by dt. C into dV. That is the instantaneous power equal to CV into dV by dt. CV into dV by dt. This is the instantaneous power. Once you know the power, how to calculate the energy stored by the capacitor. I am doing the calculation. What is the energy stored by the capacitor? Energy stored by the capacitor. Energy stored by capacitor. Stored by capacitor. I am writing clearly. How to write? What is the energy stored by capacitor? The energy stored by capacitor. The energy stored by capacitor, E or W you have to use. E equal to integral P dt. This E equal to integral. What the power calculation you done? CV into dV by dt. CV into dV by dt. Into dt. This dt cancels. Then what the energy stored by capacitor? C is constant. That is capacitance is constant. Integral V dV. C into integral V dV. What the integration of voltage with respect to dV? What the integration of voltage with respect to dV? V square by 2. C into V square by 2. Therefore, what the energy stored by capacitor, friends? The energy stored by capacitor. Important formula. The energy stored by capacitor equal to half CV square. Half into CV square. This is the energy stored by capacitor. How much energy is stored by capacitor? Half C. You can also write this formula in terms of charge. We know that Q equal to CV. From this, what is V equal to Q by C? V equal to Q by C. Then V equal to Q by C. If you substitute V equal to Q by C, then what is the energy stored by capacitor? Half into C into Q square by C square. Substitute V equal to Q by C. Q square by C square. C cancel. Then what is energy equal to, students? Q square by 2C. This one more form. Energy stored equal to Q square by 2C. So the energy calculation. How much energy is stored by the capacitor? That is equal to Q square by 2C. Clear? Any doubt? What are the current through the capacitor? What are the voltage across the capacitor? What are the properties of capacitor? And what is the energy stored by the capacitor? Capacitor stored the energy in the form of electric field. The properties of capacitor is also given here, friends. A capacitor is an open circuit to DC at steady state. At steady state condition, it acts as an open circuit. That you. The voltage on capacitor cannot change abruptly. That is, capacitor cannot allow the sudden change of voltage. Capacitor can store finite amount of energy even if the current through it is zero, because it stores the energy in the form of electric field, not magnetic field. A pure capacitor never dissipates energy, but only stores it. That is why it is called on dissipative passive element. However, physical capacitor dissipate power due to internal resistance. Pure capacitor cannot dissipate the energy, never dissipate, but only stores it. That is why it is called on non-dissipative passive element. However, physical capacitor dissipate power due to internal resistance. That's why a capacitor is a energy storage element. A capacitor is a energy storage. Energy storage element. Generally, it is a energy storage element. Pure capacitor never dissipate the energy. Only practical capacitor dissipate the energy. These are the properties of capacitor. Now, how to do some, what are the practical examples of capacitor? What are the practical examples of capacitor? Written that I will give. And before that, you will see the capacitor charging and discharging for DC and AC. How the capacitor is charging and discharging for DC and AC. Students, I told already, even in the inductance explanation also. For example, when I give the plus minus DC supply, this is positive polarity, this is negative. Once you can remove the supply, if it is short circuited, let us assume that it is short circuited. Removing the supply, then it is a short circuited through load, or let it is a short circuited through load, like this. Now the capacitor is discharging. First it discharge. Capacitor is discharging. After discharging only, it change the polarity. It changed the polarity. Now this is the capacitor. First, it is discharge. What do you mean by discharging of the capacitor? Transfer of the charge from positive plate to negative plate. But this is not the concept in inductor, sir. Inductor first reverse the polarity, then discharge, then release the energy. First reverse, then release the energy. But here, release the energy, then reverse the polarity. Finally, reverse the polarity. This is the difference. This difference I already given even in the inductor explanation also. This is capacitor charging and discharging for DC, and this is for DC. This explanation for DC. Even if you use for AC, positive half cycle, this is plus, this is minus. Negative half cycle, this is negative, this is positive. This is for AC. See the difference here? For DC, first it's storing plus positive, upper plate positive, lower plate negative. Then if it is connected with any resistance, across any resistance, then it start to releasing the energy. After releasing the energy, it reverses the polarity. This is plus, here releasing the energy. Discharging means releasing. Releasing the energy source. After releasing the energy only, it reverses the polarity. This is. But what about for AC supply? AC supply alternate cycles are alternate. Positive half cycle, this is plus, this is minus. Negative half cycle, this is negative. Again positive half cycle, it will come. This is for AC. What is the charging and discharging of the capacitor for DC and AC strips? And note I am giving, what are the practical examples of capacitors? Can anybody? What are the practical examples of capacitors? The practical examples of capacitors is, one is passive filters. You know capacitor filters, inductor filters, like that. It is a passive filters is also one of the examples of capacitor. And in pulse and digital circuits also, pulse circuits and digital circuits, pulse and digital circuits also we are using the capacitors. That also capacitive circuits. Next, phase shifting. In phase shifting circuits also we are using the capacitance. I think electrical students, you know this one, phase shifting. Take the example of a single phase induction motor. In single phase induction motor, to provide the required phase angle between main winding current and auxiliary winding current, we can use the capacitors. Capacitor start, capacitor induction motor, capacitor start, capacitor run induction motor. In that case, for phase shifting also, we have to use this one in fans. In fan, fans means ceiling fans. We are using the induction motor, single phase induction motor. Power factor correction and reactive power compensation. This all of you well know. Power factor correction and reactive power compensation circuits also capacitors are present. Reactive power compensation. Power factor correction and reactive power compensation circuits also we have to use the capacitors. Touch screen of cell phones is also having the capacitive application. Touch screen of cell phones. Touch screen of cell phones. And cursor control in laptop. Cursor control. I think in laptop, just we can, in the cursor control, how the cursor is moving. Just by touching that panel, there is a movement of the cursor. We are operating the capacitor. Touch screen and cell phones, touch screen of cell phones, cursor controlling laptops. The cursor controlling laptops also, this is happening. We have to, this is the capacitive nature or capacitance application. Transmission lines also. Transmission lines also having the capacitive nature. Transmission lines. These are some of the practical examples of capacitors. The next we will see what are the different symbols of capacitors. Its symbol consists of two parallel lines separated from each other. This is the capacitive symbols. This is fixed capacitor. If you represent like this is a polarized capacitor. If you represent like this is a variable capacitor. Flat, curved or arrow passes through it. The flat line indicates that capacitor is non-polarized. The curved line indicates that capacitor is polarized. And arrow indicates that it is a variable type capacitor. This is capacitor non-polarized. This is polarized capacitors. This is another way of capacitor symbols. This is UK capacitor symbols. Generally, we are using these symbols also. Okay, this is non-polarized. This is the polarized capacitor. This is the variable capacitor symbols. With different shapes, the capacitors are available in the market. With the different names and different shapes, different capacitors are available in the market. That all of you well know this. You please go through this. This is the electrolytic capacitor. This is the ceramic capacitor. This is the main difference. What is the minimum value and maximum value that you have to consider. Students, with this, with respect to network theory or circuit theory concepts, the RLC elements are complete. Resistance, inductance, and capacitance concepts are complete. Just what exactly resistance, resistor, minimum formulas, what inductor, inductance, minimum formulas, what the capacitor and capacitance, minimum formulas. Then before going to the next topic, how to calculate the energy in different elements, you have to see some practice questions up to now. What are the concept I explained, students? Can anybody try it? Start this. This is example 1. Right, students? Sorry. So the continuation is option C. You can check it. Come on, sir. Everybody, please write. The current in a coil changes from 5 amperes to 1 ampere in 0.4 seconds. The induced voltage is 40 volts. The self-inductance in Henry. It's a very simple question. Friends, we know that V equal to L into di by dt. How much voltage it is given? 40 volts. Inductance is, you have to calculate inductance, self-inductance. The current is changing from 5 amperes to 1 ampere. The current is changing from 5 amperes to 1 ampere. That is 5 minus 1 in how many seconds? 0.4 seconds. Then what the inductance equals, friends? This is 40 into, that is 0.4 by voltage is how much? 40 volts now. How much you got? All of you check it. I got L equal to 4 Henry. This is option C is correct. Okay, simple question. Next. A coil having 250 turns is connected to a 50 volts DC source. If the coil resistance is 10 ohms, everybody please write. Apply the concept, sir. Once we can apply the concept for solving of the questions, then we can remember the concept for a long time. Most of the students, after listening the total subject, then again they doubt is, sir, how to remember the formulas, all this. There is no any shortcuts to remember the formulas. The only way to remember the concept or formulas is, whatever the concept you prepared, whatever the formulas you practiced, you have to apply those formulas in solving of the questions. Then you remember for long. A coil having 250 turns is connected to a 50 volts DC source. If the coil resistance is 10 ohms, the MMF developed in ampere turns would be how much MMF is developed? That is option B. Is it correct? Yes. Very good, sir. Option B, that is 1250 ampere turns is correct. It's very simple. You have to, how many number of turns it is given? 250 turns. It is a 250 turns. How much voltage it is given? It is 50 volts DC source. How much resistance it is given? 10 amperes. So resistance is 10 ohms. Then you find the current in amperes. I equal to V by R. That is 50 by 10. That is 5 amperes. How to calculate MMF? Magnetomotive force now. MMF equal to N into I. That is 250 into 5. That equal to 1250 ampere turns. 1250 ampere turns. Very good. 1250 ampere. That is correct. Next. Can anybody answer this question? Come on, do it. Example 3. A unchanged capacitor of 0.01 farad is charged first by a current of 2 milliamperes or 30 seconds, and then by current of 44 milliamperes for 30 seconds. This is for 30 seconds. The final voltage it will. The final voltage. Come on, friends, do it. For 0 to 30 seconds, the current is 2 milliampere. 2 milliampere. After that, next 30 seconds, the current is 4 milliampere. Students, we know this. Voltage across the capacitor equal to Vc of 0 plus 1 by C integral 0 to T idt. Correct? Now V equal to, here initial voltage across the capacitor is not given. Take 0. Initial voltage across the capacitor is not given. Take 0. What the capacitance? 0.01 farad. Integral 0 to 30 seconds. 0 to 30 seconds. Current is how much? 2 milliamp. Current is 2 milliamp into dt. Now, this V equal, this is the voltage across the capacitor. 1 by 0.01 integrate, students. If you integrate 2 milliampere 2 into 10 power minus 3 is constant. Integration of constant is t 0 to 30. Now you have to substitute the limits. How much voltage we can get? And 0, 1 into 2 into 10 power minus 3 into 30. How much you get, friends? This approximately equal to, this is 60, 10 to the power of minus 2, that is, this is 10 power 2, 6 volts. Is it correct? This is 6 volts for 0 to 30 seconds. For next 30 seconds, 4 milliampere. For next 30 seconds. For next 30 seconds. Then now what is the voltage across the capacitor? Vc of 0 plus integral. Next to 30 seconds means 30 to 60 seconds. 30 to 60 seconds. What the current? Current equal to 4 milliamp into dt. Next 30 seconds. Now tell us, friends, what is the initial voltage? For next charging, what is the initial voltage? For next charging, what is the initial? This is the initial voltage. For next charging, this is the initial voltage. Already voltage across the capacitor is 6 volts. Before 30 seconds, voltage across the capacitor is 6 volts. Now I am taking, this is the initial 6 volts. Then 4 into 10 power minus 3. Integration of constant is t, 30 to 60. Now, can anybody? What is the answer? 4 into 10 power minus 3 into 30 to 60 to 60 minus 30. Integrate, substitute the limits. How much voltage you got? This is 30 into 4. How much, friends? One by C, no? I forget 1 by C, please. This 1 by C is there. 1 by C, 0.01, 1 by C, please. Correct it. Once again, I'm writing. Don't forget 1 by C. I'm writing once again. This is 6 plus 1 by 0.01 into, that is 4 into 10 power minus 3 into 60 minus 30. 60 minus 30. Integrate. We can get t. After t, you substitute the limit. 60 minus 30. Yeah, this is how much, friends? 6 plus 4 into 10 power minus 3 into 10 square into 30. To 30. That is 6 plus, this is 120. 120, that is 12. This is equal to 18 volts I got. Is it correct? This is the 18 volts. See the very important model. First 30 seconds, I got 6 volts. First 30 seconds, I got 6 volts. Then again, it is charging from 30 seconds to 60 seconds. Next 30 seconds. Next 30 seconds means 30 to 60. For next charging, this is the initial voltage. For next charging, this is the initial voltage. Then total is, we got the 18 volts is the answer. Very good. Option B is the right answer. Can anybody answer this question? Come on, do it. This model is framed in gate exam. The voltage and current waveforms for an element as shown in figure. The circuit element and its values are. So first identify the element. First identify the element. V equal to L into di by dt. First I am taking the element. V equal to L into di by dt. This L into d by dt of, this is current. If you current is which one? Ramp. Differentiation of ramp, what you can get? Differentiation of ramp, we can get step. That is differentiation of current, we are getting the step. Step is nothing but which one? Voltage. Differentiation of current, we are getting voltage. Voltage is the step. That's why, what is the element? Element is inductor. Element is inductor. Correct or not? Sir, it's very simple, sir. You check for inductor and capacitor also. First, I am checking for inductor. V equal to L into di by dt. Differentiation of current. Current is which one? Ramp. Ramp is differentiated step. Are you getting the differentiation of current? We are getting step now. Satisfied? That's why element is inductor. Now we have to find what is that inductance value. What is V equal to? L into di by dt. How much voltage it is given, friends? Voltage equal to 2 volts. Inductance. During this 2 seconds, time, how the current is changing? Current is changing from 0 to 2 amperes. The current is changing from 0 to 2. That is 2 minus 0 by, what is the time? Time is changing from 0 to 2 seconds. 2 minus 0. Then what is L equal to, friends? L equal to 2 Henry. It is the inductance. The inductance equal to 2 Henry. Option C is correct. Any doubt? First, identify the type of element. How you have to identify the type of element? Write down the formula. Inductor formula and capacitor. You check this is capacitor. IC equal to C into dV by dt. C into d by dt of, what is the voltage? Voltage is step. What is the differentiation of step? Impulse. Is it a current is impulse? No. That's why it is not a capacitor. It is not satisfying. That's why it is not a capacitor. Correct or not? Current is not a impulse. Current is which one? Ramp. Are you getting ramp if you take the capacitor formula? No. That's why this element is not a capacitor. This element is an inductor because this property, this relation is satisfied. Check the both the relations. Which of the relation is satisfied? That element, that is the element. Inductor relation is satisfying or capacitor relation is satisfying, that you have to check it. But here inductor relation is satisfied, that's why it is inductor. V equal to L into A by dt. Current is changing from 0 to 2 during 2 seconds. Then 2 minus 0, L equal to 2 Henry. Next. A heater element is made of nichrome wire having resistivity equal to 100 to 10 to the power of minus 8 ohm meter. The diameter of the wire is 0.4 millimeters. The length of the wire required to get a resistance of 40 ohms, 1000 watt. The diameter of the wire required to get a resistance of 40 ohms, 1000 watt. The length of the wire required. How to solve this? This is actually, it's not inductor and capacitor related question. This is the resistance related question. What the resistivity it is given? Resistivity equal to 100 into 10 to the power of minus 8 ohm meter. Students, we know that R equal to rho L by A. Rho L by R equal to rho L by A. First, you calculate A equal to pi R square. Because diameter is given, you have to apply pi R square. What is the radius? Radius equal to diameter by 2. That is 0.2 mm. You substitute here pi into R square, 0.2 mm, 0.2 into 10 power minus 3 whole square. Then what is the area you can get? You simplify this approximately, we can get 0.1256. Do the calculations. 0.1256 into 10 power minus 6. Correct? 0.1256 into 10 to the power of minus 6. Students, you have to find L value now. What is L equal to? RA by rho. RA by rho. R is how much it is given? 40 ohms. R equal to 40 ohms. A is how much you calculated? A equal to 0.1256. 0.1256 into 10 to the power of minus 6 by rho. Rho is how much? 100 into 10 to the power of minus 8. What value got? This is 40 into 0.1256 into this 10 power minus 8, this 10 power minus 6, no? 10 square by 100. This is cancelled. 40 into 0.125. This is 1.256 into 4. This is approximately equal to 5 meters. The length equal to 5 meters. Is it correct? This approximately equal to 5 meters. If you want, write here directly. This will cancel now. No need write. This 10 power minus 6 cancel. This is equal to 5 meters approximately. Then what is the length of the wire required? The length of the wire required equal to 5 meters. That you have to consider. Clear? Clear, sir? Every model you have to practice. Then you get idea. If any different problem is also asked, you can easily get the idea how to proceed. A pulse of plus 10 volts in magnitude and 2 seconds duration is applied to the terminals of a lossless inductor of 1 Henry. The current in the inductor would be, you have to find the what is the current in the inductor source. A pulse of 10 volts in magnitude and 2 seconds duration. How to proceed? First you write down a pulse of, first I am writing pulse waveform. A pulse of 2-second duration. This is the 2-second duration. Magnitude is 10 volts. 10 volts magnitude. Magnitude is 10 volts. Yes, magnitude is 10 volts. This is T is in seconds. And this is the voltage. It is applied to inductor. It is applied to inductor. Then what is the current? You have to find the what is the current. You have to find the what is the current source. The current through the inductor would be. We know that V equal to L into di by dt. Then I equal to 1 by L into integral V dt. 1 by L into integral V dt. 1 by L into integral V dt. Okay, next. Then I equal to 1 by L, that is 1 by 1 into integral V. Voltage is which function? Step function. Voltage is step function. Step function. Voltage is step function. This is I equal to what you can get? 1 into integral. Step is how much it is? V is 20. 10 or 20 steps. Let's say voltage is how much? 10 volts. A pulse of 10 volts. This is 10 dt. Voltage is 10 dt. Then what is I equal to 10 t? 0 to 2 seconds. No? This you have to take 0 to 2 seconds. 0 to 2 seconds. This is 10 into 2. This is 0 to 2. No? 0 to 2 seconds. This is 20 amperes. This 20 amperes current is integration of step. No? Integration of step is nothing but a ramp. Integration of step is nothing but a ramp. That is, if it is a ramp, means what type of current it is? Integration of step is ramp. No? This linearly increases to, it is linearly increases like this. This remains constant of 20 amperes. That is, for 0 to 2 seconds, the current is linearly increases to 20 amperes. Thereafter, it remains constant. Thereafter, it remains constant. Which option is correct? Very good. C is correct. Understand, sir, how to proceed? You find the shape of that current. It is a step. It is a ramp. Increases linearly from 0 to 20 amperes in 2 seconds. And in the positive direction. It is in the positive direction only. And thereafter, the current is remains constant of 20 amperes. That is, option C is the right answer. Clear? All are followed? Any doubt? Once again, you have to practice all these ones. Can anybody answer this question? A triangular wave voltage as shown in figure is applied across the terminals of 0.5 picofarad pure capacitor. The corresponding current wave is no, maximum only that waveforms only we can expect. Don't have any other waveforms. Even that waveform, even in signals and systems also same concept. Okay, you have to follow only that. That is step, ramp, and parabola, and there is a square and a triangle. Square and a triangle. That is only enough. Square and triangle. Now here I given the triangular related and square related. Yes, a triangular wave voltage as shown in figure. Then corresponding current wave. Voltage is triangular. IC equal to C into dV by dt. If voltage is triangular, IC equal to C into d by dt of voltage is triangular. What the current? Voltage is triangular. What the current? Current is square wave. Current is square wave. If the current is square wave, then we can easily identify this is not the answer. This is not the answer. Clear? It's not the answer. This is not the answer. Now you have to check for 0 to 1 ampere. Yeah, it is a square wave. But you have to identify, is it A is the answer or B is the answer? You have to identify, is it A is the answer or B is the answer? Can you try for any 0 to 2? You have to try for 0 to 2. Try for 0 to 2. I have to calculate what the current for 0 to 2. For 0 less than t less than 2. For 0 less than t less than 2. What is IC equal to? C into dV by dt. Capacitance is 0.5 farad. Capacitance is 0.5 farad. Yeah. It is changing from plus 10 volts to minus 10 volts. Plus 10 volts to minus 10 volts. Always you have to apply final value minus initial value. Final value is minus 10. Initial value. Or if you take initial value, okay, no problem. You take initial value minus final value also. It's very simple, sir. Simply remember, if you take this is initial minus final, time also you take initial minus final. If you take voltage is final minus initial, time also you take final minus initial. Follow that procedure. Okay, I'm taking initial minus final. 10 minus half minus 10. You have to take time also minus initial minus final. Same procedure you follow. 0 minus 2. Don't take one is final minus initial, another is initial minus final. Follow the same. 0 minus 2. Then what is IC equal to? 0.5 into 10 minus half minus 10, 20. 20 by minus 2. 20 by minus 2, I got minus 5 amperes. 0 to 2 seconds is the minus 5 amperes. Now which option is correct? Which option is correct? 0 to 2, current is minus 5 amperes. It's not plus 5 amperes. That's why A is not the answer. B is the answer. It's a square wave, no doubt at all. First, you have to calculate. Check for any one. Because 0 to 2, you have to check. Remaining, you have to calculate. No problem. Can you try for, this is 0 to 2. Can you try for 2 to 4? 2 to 4. 2 to 4. You take initial minus final. Time also you take initial minus final. If you take, this function is final minus initial. You take time also final minus initial. Follow the same procedure for function and time. That is minus 5 ampere. That's why remaining no need to solve. Remaining no need. You try for 2 to 4. What is IC? You try for 4 to 6. 4 to 6. What is IC? This I'm leaving for. 2 to 4, 4 to 6, you try. We can get this 2 to 4, we can get 5 amperes. 4 to 6, we can get 5 amperes. You try that. Clear? Yeah, this model is also important that you have to concentrate. Next. Now, can anybody answer this? Fraction of minute you answer. Answer it. Come on, do it. First, identify the element. Identify the element. First, I'm checking for inductor. Yes, friends. V equal to L into di by dt. V equal to L into d by dt of this is parabola. Current is parabola. Current is parabola. In differentiation of parabola is which one? Ramp. Satisfying or not? Voltage is ramp. Hence, element is which one? Element is which one? Inductor or capacitor? It's inductor. Clear, sir? Current is parabola. Parabola is differentiated. I'm getting the ramp. That is satisfied. That's why element is inductor. You have to find that inductance value. Then V equal to L. L is how much? Inductance. You have to calculate. L into the current is changing. Instead of current, because it is a parabola, but finding that equation is difficult. Finding that equation is somewhat difficult. Better to go for like this. I equal to 1 by L integral V dt. This is correct. Na? I equal to 1 by L integral V dt. How much current? Current equal to how much voltage swings? Yes. What is the answer you got? Option D. Inductor. Is it 5 Henry you got? Is it correct? Once again check it. The voltage and current characteristics of element as shown with the nature and value of elements. You have to find value of elements. The nature is the inductance. The nature is the inductance. Then you have to find the what is the elements. See, the current is changing from 0 to 2 seconds on. Current is changing for 0. This current is changing for 0 to 2 seconds. Don't take 0 to 2.5. 1 by L integral 0 to 2 only I'm taking. Because the current is changing from 0 to 2 seconds now. That's why you have to take the 0 to. What is V, sir? What the equation of this V? How to find what the equation of V? For 0 to 2 seconds only, how to take 0 to 2 seconds. If you take for 0 to 2 seconds only, then if you find the slope of this curve for 0 to 2 seconds, if you find the slope of this one, then V of t equal to, it is a ramp now, V of t equal to 10t. This is the ramp, V of t equal to 10t. V by, this is 20 by 2 now, 10t. That I'm writing 10t into dt. Then how much you can get this? T square by 2 now. Inductance is how much? You have to calculate this. 1 by L into, this is t square by, this is how much, friends? T square by 2. T square by 2 into 10. This is equal to, I equal to, this is 5 by L, 5 by L into t square. 0 to 2 limits. This is equal to 20 by L. You can 5 by L into 2 square minus 0. This is equal to 20 by L. That I equal to 20 by L. I equal to 20 by L.
So isn't the slope 8t rather than 10t?
Slope is?
So the slope, shouldn't it be 8?
How much slope you got? 80.
Yes, sir.
Yes, if it is a 8. It is not a 2.5 seconds, it is a 2 seconds. Current is changing here, 2 seconds is also 2 seconds. How to check it this? Please correct it. This is not 2.5. You take this is 2 seconds. Okay. Now is it correct? Slow. 20 by 2 into t. Na? This is 10t. Correct? Now is it okay? Because you have to calculate because current is given for 2 seconds. Then voltage variation also you have to take for 2 seconds. It's not 2.5 seconds, it's a 2 seconds. Then it is a 20 by L. This is 20 by L. Now tell me, at t equal to 2 seconds, what is I? At t equal to 2 seconds, what is I? How much? It is 8 amperes. 2 equal 2 seconds, at t equal 2 seconds, current is 8 amperes. Substitute 8 equal to 20 by L. Then what is L equal to? 20 by 8. I got 2.5 Henry. Is it correct? Sir, the voltage variation must be 2 seconds for 2 seconds. This also for 2 seconds. Please, is some type mistake. You have to correct it. It's a 2 seconds. I got the 2.5 Henry. This is the inductor. That's the 2.5. Is it okay? Clear? It's not 80. It's a 10t only because you have to take, if according to, if you take 2.5, then it is the 80. If you take 2.5, that is 80. But you have to calculate for same duration, voltage and the current duration for same. That's why it is a 2 seconds. It is also for 2 seconds. Then L equal to inductor equal to 2.5 Henry. That is the correct. Can anybody answer this? The voltage and the current waveforms for element as shown in figure. The circuit element is. What is the circuit element? Current is ramp. Voltage is step. That is, if you integrate the voltage only, we can get the current. Integrate the voltage only, we can get the current. Shall I write like this? IC equal to C into dV by dt. No, you don't get it. Shall I write like this? V equal to L into di by dt. V equal to L into di by dt. If you differentiate the current, we can get the voltage. Correct or not? L into d by dt of I. I is which one? Ramp. Ramp differentiation is step. Satisfied or not? Then you find the element. The element is which one? Inductor. The element is inductor. Then same question repeated. The element is inductor. What is the voltage? Voltage equal to 2 volts. Inductance you have to, same question I think. 2 minus 0, 2 minus 0. Is L equal to 2 Henry. Same question it is repeated. It is inductor and it is a 2 Henry. Can anybody answer? Fraction of minute you can answer. The waveform of current flowing in a pure inductor as shown in figure. Pure inductor as shown in figure. Then what is the waveform? It is a UPSC question. UPSC. This ICS now. This is UPSC questions. Civil services. What the answer, sir? Come on. You have to find voltage now. V equal to L into di by dt. L into di by dt. L into d by dt of, it is a ramp. This is a ramp. Ramp is step. Or if it is a triangular, now, if you take triangular wave. If it is a triangular waveform, you can get square. You take as a ramp or triangular. I'm taking as, if you take the triangular waveform, triangular, then you can get the square wave. But you have the doubt here. Is it B is correct or C is correct? It's very simple, sir. See this one. For this starting, it is a positive ramp. If it is a positive ramp, we can get positive step. This is falling ramp. Falling ramp, negative step. Again, rising ramp, positive step. Falling ramp, negative step. Then which option is correct? It's a B is correct. Don't take C. See the concept here. It's a positive ramp. Positive ramp is nothing but a positive step. Negative ramp is nothing but a negative step. I am analyzing as a ramp function. Even square function also, You can get like this. Triangular also as a square. But it will not start negative. It starts positive because of positive. Clear? Clear, sir? That's why option B is the right answer. No need to solve anything here. Just you have to check it. Yes, you have to try this homework for practice. If you are solving any practice question, if you have any doubts, you please share in my Telegram channel. Then I will give the solution. Try this also. This also practice. Practice this also. And this also you have to practice. During practicing these questions, if you have any doubts, you please share in Telegram channel. And this also you have to practice. Please try to solve whatever the models I'm covering in class and whatever I'm giving for practice. Please first complete that. Still time is there, then try for other questions also. Maximum GATE ESE questions and some practice questions answer. Students, with this, with respect to basic elements, resistor, inductor, and capacitance calculations are completed. But one more important topic that is so many times it is asking in competitive exam, how to calculate the energy in RLC elements. How to calculate the energy in resistor, inductor, capacitor. If RL series combination is given, RC series combination is given, RL parallel combination is given, RLC parallel combination is given. How to calculate the energy calculation in resistor, inductor, and capacitor. Friends, this is also very important concept. In the next session, I will continue with this. This is about the today's session. Any doubts, sir? All these models that I will. Any doubt? Okay, thank you. I'm ending the session. I will share this PPT. Please once again, please go through this. During solving of the practice questions, homework questions, if you have any doubt, please share in my Telegram channel. Then I will share the solutions. Okay, thank you. Ending the session.